Hello students, welcome back to the fifth video of this playlist. So in this video we will be solving the fifth question from Statistics 1 October 2023 paper. So let's see what's the question number 5 from this paper is about. So basically the concepts behind question number 5, it's from normal distribution that has been discussed in chapter number 7. That is the last chapter of your Statistics 1 textbook. So let's get started with question number 5. Okay. The weights x grams of a particular variety of fruit are normally distributed with x distributed normally with mean 210 and variance 25 squared. Okay, a fruit of this variety is selected at a random. Okay, so they are selecting a fruit of this variety at random. So now they asks to show that the probability that the weight of this fruit is less than 240 grams is 0.8849. We need to show that the probability that the weight of this fruit is less than 240 gram is this much. Okay, let's see. So we know that it is the weight of the fruit is normally distributed. So what we can write, probability of weight is given by x. It's less than how much? It's less than 200. Oh, sorry, not 200. It's 240. 240. It's what we need to find out. So standardize. Okay, so why we need to standardize? Because the table that is given in the formula booklet, it's basically for the standard values of z. That is the probability of z. It's the standard values of z, right? So standard values of z means the z is distributed with mean 0 and the variance 1 squared. So since the table that is given in the formula booklet, it's for standard values. Okay, so that's why we need to standardize the data and to make the to make it comparable with the table that is given in the booklet. Okay, so for standardization what we need, 240 minus the mean. The mean of this data is how much? 210, if I'm not wrong. This is 210 over the standard deviation, that is 25 in this case, right? Isn't it 25? It's 25, yeah. So what's the value here? 240 minus 210, which is 30 over 25, which is 6 over 5. So probability of z less than or equal what? 6 over 5. So let's find out that probability. So 6 over 5 is basically 1.2. So you can get it from the formula booklet. Let me show you fast. So go to normal distribution. You can find the normal distribution table here in the formula booklet. Okay, so next we need to find the value, the probability for z less than or equal 1.2. Where is 1.2? Look, here you go. This is 1.2. Okay, 0.8849. Make sense? So we got the probability of z less than or equal 1.2. It is 0.8849, and that's what the exactly question asked for. Okay, so we got it's 0.8849. 0.8849. Done. Okay, next what they have asked, this is part B. In part B they asked to find the probability that the weight of this fruit is between 190 gram and 240 gram. Okay, we need to find out the selected fruit. The selected fruit has weight between 190 gram, that is greater than 190 gram, and below 240 gram. Okay, so we need to find out that probability. Look, so That's what? For part B, probability of X greater than 190, okay, and less than how much? Less than 240, right? Okay, so this is basically what? Probability of probability of X less than 240. From that probability, if you subtract the probability of getting X less than 190, you will get the wanted one. Okay, so X less than 240, we already know this probability, which is 0.8849. we found just in part A, right? So this can be written as 0.8849 minus, you just need to find out the other one. Okay, you just need to find out the other one. So that would be what? Probability of X less than 190. Okay, it can be written as standardize, right? Z less than or equal 190 minus 210 over how much? 25 is the standard deviation. So this is negative 30. Probability of Z less than or equal what? Negative 20 over 25. 20 over 25, which is negative 4 over what? 5. Okay, so what would be that probability? Look, this is negative 4 over 5, but in the table, in the distribution table, normal distribution table for the standard values, okay, you can't find negative values, right? So basically we need to use it's till 0 only. We can't find negative, so we need to use the concept from what? The bell curve. Okay, so if I show you a bell curve, consider this is a bell curve. So have a look. That's how a bell curve looks like. Okay, so this is basically the mean. Okay, this is basically the mean, where mean is what? 0, because standard data Z is distributed normally with mean 0 and standard deviation 1, right? Okay, so negative 4 over 5, right? So negative 4 over 5, definitely it lies on the negative, on the left side of the mean. So this is negative 4 over 5. So probability of Z less than or equal negative 4 over 5, it's basically the area under the bell curve represents you the what? Probability. So this area and then that area, using symmetry, it is symmetrical. Remember, this is totally symmetrical. This is 4 over 5. Above that area, these are what? Equal, using symmetry. Okay, so that means what? Probability of Z less than or equal negative 4 over 5, it is equals to probability of Z greater than or equal 4 over 5, and we need to represent it in the form of less than or equal in order to make it comparable with the given table in the booklet. So which is, if you subtract this probability, like if you subtract probability of Z less than or equal 4 over 5 from 1, you will get the probability of Z greater than or equal 4 over 5. Understand? So that means this probability that we got here, the one we got here, we can represent it. Okay, we can represent it like this: 1 minus what? So 1 minus probability of Z what? Less than or equal 4 over 5, right? So what's that probability? This probability is basically 0.8. 4 over 5 is 0.8. For 0.8, let's check it out. Z less than 0.8. 0.8, why it is, look, 0.7881, right? 0.7881. This is basically 0.7881. Okay, we got it. So this is 0.7881. So 1 minus what? 0.7881. 0.881. So what would be the value here? 1 minus 0.7881 is what? This is basically (0.2119), okay, which is basically 0.2119. So we got that probability, right? So now what it would be here? 0.2119. Okay, so the answer we will get here, it is what? 0.8849 minus 0.2119. So what you will get? You will get 0.673. 0.673, and that's the answer for part B. Done. Next is part C. For part C, they are asking to find the value of k such that probability of x greater than 210 minus k less than 210 plus k, this is equals to 0.95. So this is basically, we need to use concepts from the bell curve. Okay, 210 minus k and 210 plus k. So we know that the mean is 210, isn't it? Right? The mean is 210 here. Okay, so let me show you using a bell curve to make you more understand about that fact. Consider the bell curve again. So if you consider the bell curve, looks like this. This is the mean, right? So this is the mean. So this is the mean 210, right? So 210 plus k, this should be symmetrical, isn't it? So this is 210 plus k and this is 210 minus k. Okay, so this is 210 plus k, this is 210 minus k. Okay, so this probability is given, as how much? 0.95. That means the area under the the bell curve shows us the probability. That means this area is basically 0.95. So since this area is 0.95, so what we can consider, using symmetry, we can say that we can say that this area and that area will add up, will both add up to give what? 0.05. Okay, 1 like 0.05 plus 0.95, it is total 1. We know that sum of the all, like the area under the whole bell curve should be 1, since the total probability is 1 always. Okay, so that means what we can write here, this is 0.025. okay, only this one, and that is also 0.025 using symmetry. Okay, so for part C, what we can write, probability of x less than 210 plus k, it is equals to how much? 0.025 plus 0.95, it gives you what? We need the total area under this one, right? For less than 210 plus k, right? So this is 0.975. This is 0.975. Okay, so now standardize the value. So less than or equal 210 minus plus k minus 210. So 210 cancels out, so we'll get k over 25, the standard deviation. This is equals to 0.975. okay, now we need to take a value from the table. Okay, 0.975, isn't it? So look for 0.975, 0.975, 0.975, where it goes. Look, we got it. This is 0.9750. Exactly the value is given here. Okay, if you have a class with 991E X calculator, then you can directly find out that value using inverse normal. I will show you 1.96, we got the value for z here. It is what? 1.96. Okay, that means the value for k over 25 is what here? So k over 25, this is equals to what? 1.96. Okay, so k equals to what? 25 times 1.96. 25 times 1.96, that would give you exactly 49. Okay, so what I said, if you have a class Viz 991EX calculator, then after switching it on, press mode and then press 7, that is distribution, and then go for inverse normal, that is on the third. So press 3. Then they asks for area, so for area you will put 0.975 and then press equal. You will get the value 1.9599 something. So to 2 decimal place it is 1.96. Okay, so done, we got the value for k. Next, part D. Okay, what they have asked in part D: a wholesaler buys large numbers of this variety of fruit and classifies the lightest 15%. The lightest 15% as small. So find the maximum weight of a fruit that is classified as small. Okay, so we need to find out the smallest, the greatest possible weight, so that the selected fruit, the selected variety of fruit, will be still considered as what? Small. Okay, that is the threshold for the small fruit. Okay, so this is the bottom 15%, right? This is the bottom 15%. So for bottom 15%, for part D, what would be the case? Probability of x less than, we will need to find out the value for x. It is x. Okay, this is equals to 0.15. So x is the bottom, like the greatest weight. Okay, so standardize, so that less than or equal x minus 210 over what? 25. This is equals to 0.15. Okay, so now we need the bottom 15%, right? So basically bottom 15%, if I show you the bell curve, bottom 15%, you can say, if you consider this part, this would be the bottom 15%, okay, which is below the mean, and it lies in the negative value. The value for z would be negative. So this area and the top 15% area is the same using symmetry, right? So if we go for the greater than table, go to greater than table, and if you consider the maximum, the greater, it is the greater than table, it shows probability of z greater than or equal the value. This probability is given here. Okay, so we need the top 15%. So top 15% is 0.15p, right, which is here. Okay, so corresponding to that, the standard value is 1.0364. Okay, so this is positive, but we need the smallest. This is positive because this is the top what? Top 15%, that's why. But we need the bottom 15%. So probability of z less than or equal, it's negative, its corresponding negative value would be what? Same, using symmetry of the bell curve, right? Okay, so we got the value for z. This is negative 1.0364. Negative 1.0364. Okay, this is what? So x minus 210 over 25, negative 1.0364. Okay, you can also use your calculator, mode 7, then press mode, at first press mode and then press 7 and then press 3, and then you will get the area, that is 0.15. You will get the value negative 1.0364. Okay, So now find out the value for x. Okay, negative 1.0364 times 25, okay, plus 210, that would give you 184 point what 09, the maximum weight of a variety of fruit, such that it will be still considered as a small fruit. It is 184.09. okay, now what should be the final value? Should be in 1 decimal place or 3 significant figure? 3 significant figure, since they didn't mention anything, so give the final answer to 3 significant figure. Okay, so x is what 184. okay, the value for x is 184. Done. Part D is done. So they ask for maximum weight, so write the unit, that is it's grams. 184. okay, we will write it there, 184 grams. okay, so the weights y grams of a second variety of these fruit are normally distributed with y distributed normally with what normally with mean what mu, and the variance is what sigma square. okay, so it's given there. So what we need to find out here, okay, before finding out, they have said something in before part E. This is given that 5% of these weigh less than 152 grams. What? 5%. okay, 5% of the fruits, that is variety of fruit, y variety of fruit. okay, 5% of the second variety of fruit, it is basically less than, it weighs less than 152 grams. okay, and 40% weigh more than 180 grams. So we need to find out in part E. They are asking to find out the mean and the standard deviation. okay, so we will use this like the data what they have said here. Y less than 152 gram, it is 5%. Y for part E, probability of y less than 152, it is how much? 5%, that is 0.05. Now standardize the data. So probability of z less than or equal what 152 minus the mean over the sigma, this is equal to what 0.05. okay, so this is what we have arranged from the given data, that is the 5% of the second variety of fruit weigh less than 152 grams. okay, so considering that fact, we need to find out what corresponds to 5%, right? Less than of that, less than that is 0.05. that means the bottom 5%, isn't it? okay, bottom 5%. so for bottom 5%, let's see the what greater than table. Bottom 5% is basically same as the top 5%, isn't it? So consider that bottom 5%, top 5% is 1.6449. so for bottom 5%, it will be negative 1.6449. make sense? So for what the bottom 5%, it will be negative, since it lies below the mean. So what we can write, 152 minus the mean over the sigma, this is negative 1.6449. okay, so we need to find out the mean and the standard deviation. okay, so what you can do, this is what we got here. We can make the mu, the sigma the subject. If you make sigma the subject, you will get 152 minus the mean over negative 1.6449. okay, we got the substitute for sigma. okay, now we have to make simultaneous equation using the next data that is given in the question, which is 40% weigh more than 180 grams. Okay, 40% weigh more than what? 180 grams. So probability of y greater than 180, it is equals to what? 40%. That means 0.4, right? So if I make it less than, so y less than or equal 180 would be how much? So less than 180 would be how much? It would be 1 minus 0.4, right? Which is 0.6. So now standardize. So probability of z less than or equal 180 minus the mean over the standard deviation. This is equal to 0.6. So now you can use your calculator mode, then press save and then press inverse normal, and then we need 0.6 area, that is 0.2533. you can get it from the booklet also, that is 0.2533. okay, so what we can write here is that 180 minus the mean, 180 minus the mean over the sigma. Okay, this is equal to how much? 0.2533. okay, now same, we can make sigma the subject, so we will get 180 minus mu over 0.2533. okay, so we can equate them, isn't it? 180 minus mu over the sigma, not sigma, 0.2533, this is equals to how much? This is equal to the previous equation for mu, previous equation for sigma, okay, 152 minus mu over negative 1.6449, negative, so 152 minus mu over negative 1.6449. okay, now we need to make mu the subject, so cross multiply, so negative 1.6449 times 180, it gives you negative 296.082 plus 1.6449 mu equals to what? 152 times 0.2533, you will get 38.5016, okay, minus 0.2533 mu. okay, now take the terms with mu on the same side, so 1.6449 plus 0.2533, you will get 1.8982. just solving simultaneous equations, that's it. 8982 mu, that would be equal to 38.5016 minus, it will become plus since it was negative on the left hand side, so plus 296.082. okay, so you will get 334.5836. now we need to make mu the subject. If you make mu the subject, what would be the value for mu? 334.5836 over 1.8982. this is basically 176.26 something. okay, 176.263, it keeps going. now use the exact value of mu, using the exact value of mu, using this and using this equation, find out the value for sigma. okay, so we need the value for sigma. It's a bit long calculation. So 180 minus sigma, 180 minus mu, mu is what you got in your calculator, so 180 minus the answer, that is 176.263 something, answer minus, okay, 180 minus answer over 0.2533, so this is basically 14.750881. Okay, and it keeps going, irrational number 14.7508, it keeps going. So mu, how many decimal places we should consider? 3 significant figures, or you can consider 1 decimal place since it's a large, it is an irrational number. So consider 1 decimal place, which is 176.3, and the sigma, it is basically 14.8. Done. So this is the value for the sigma and the what? And the mu, the mean of the y variable. And that's all about question number 5 from October 2023 Statistics 1 paper. That's it.